When we calculate the interval estimate of population mean in one sample, there are various possibilities. In this module, we will talk about the interval estimate of population mean when the population variance is known. In order to develop an interval estimate of a population mean, the margin of error must be computed using either the population standard deviation sigma or the sample standard deviation s. But that would be in the case when sample size is pretty large. Usually the sigma is unknown, or we rarely know exactly what the value is. But often a good estimate can be obtained based on historical data or other information. Here, we refer to such cases as the sigma known cases. There is a 1 minus alpha probability that the value of a sample mean will provide a margin of error of z alpha by 2 times the standard error or less. Since we talked about that x bar follows the normal probability distribution, we have a normal curve plotted here. And the sampling distribution of x bar would be represented by this normal curve, where the blue shaded region talks about the alpha by 2s, whereas the central region that is green is 1 minus alpha of all x bar values. The central region will cover the confidence region. Over here, we can notice that if our interval estimate stands here, and this is our point estimate, or this is our true value for the population mean, then this interval does not include the true value, whereas this interval and this interval, both of them, includes the value of the population mean. So if we have to compare these three intervals, this interval and this interval, both of these intervals are considered the better interval because they do include the population mean in them. So while calculating the confidence interval for single mean, the expression for the confidence interval is x bar plus minus z alpha by 2 and the standard error of population mean, where x bar is the sample mean, 1 minus alpha is a confidence coefficient, z alpha by 2 is a z value providing an area of alpha by 2 in the upper tail of the standard normal probability distribution, sigma is a population standard deviation, which we assume that it is known to us, and n is the sample size. We use all this information, and to calculate z alpha by 2, if we calculate the 5% level of significance, we take up 1.96, and likewise for other level of significance or confidence levels, we take the values respectively. So because 90% of all the intervals constructed using x bar plus minus 1.645 sigma x bar will contain the population mean, we say we are 90% confident that the interval x bar plus minus 1.645 sigma x bar includes the population mean mu. We say that this interval has been established at the 90% confidence level, and the value 0.90 is referred to as the confidence coefficient. Let's take an example. A physical therapist wished to estimate with 99% confidence the mean maximal strength of a particular muscle in a certain group of individuals. He is willing to assume that strength scores are approximately normally distributed with a known variance of 144. A sample of 15 subjects he took who participated in the experiment that yielded the average of 84.3. In this situation, we are given sample mean, sample size, and population variance. We are also given that what is our confidence coefficient, and it is 99% confidence coefficient. Using this given information, the z-value corresponds to 0.99 is found in the table that we just talked about, is 2.58, which is our reliability coefficient. The standard error is sigma x bar, which is sigma over under root n, is 3.0984, where the sigma value is the square root of this variance. Our 99% confidence interval mean then is given by 84.3, which is x bar, plus minus z alpha by 2 sigma x bar. This is sigma x bar. This is the value of z alpha by 2, and this is the mean that we obtained from the sample. Solving it, it gave us two estimates. One value is 76.3, the other value is 92.3. Here we say that we are 99% confident that the population mean is between 76.3 and 92.3. Since in repeated sampling, 99% of all the intervals that could be constructed in the manner just described would include the population mean. Population variance is usually unknown. Hence, we estimate the variance from the sample. In this situation, we can use the t-distribution to calculate the confidence intervals.